Algebra 1, 12.2c, graphing functions. If you haven't watched 12.2a and 12.2b, I really wish you would before you watch this video so you don't get confused or lost. And there's links in this video's description that'll let you go right to them. And then maybe you can come back to this one, okay? When the domain of a function has an infinite number of values, we graph the function by graphing some of the ordered pairs. Now, a graph is more accurate if the pairs aren't too close to each other. So when we're graphing ordered pairs, I want you to remember that if you pick ordered pairs that are really close to each other, then it's going to be really hard to make an accurate graph. When you pick numbers that are farther apart from each other, we know our graph is more accurate. Okay, that's just a little side note to help you. All right, so if you had a function table, you could graph this one and then skip way over to this one so you've got space between them. If you try graphing these two next to each other, the points might be too close together. That's all I'm trying to say, okay? So if we need to graph the function g of x equals the absolute value of x, and then find the range, we can't list all the ordered pairs for this function because there's an infinite number of real numbers that'll make it true. The absolute value of x can be a negative or a positive, can't it? It's just how many hops away it is from 0. But we can list some of the values in a function table and then graph those values as coordinates of points. So again, absolute value is a number's distance from 0 on a number line. So the absolute value of 5 is 5. It's 5 hops away from 0. And the absolute value of negative 5 is a 5 because it's 5 hops away from 0. See? So any value for x that's negative or positive, it's going to be a positive. See that? Because of the absolute value. So we end up with a graph that looks like this when we plot these points. And because the range in the output has an infinite number, we use set builder notation. When the answer has an infinite number of answers, we use set builder notation. And to represent y, this g of x, the function of x, we can write the set of all y such that y is greater than or equal to 0. And then that'll represent y, see? And there'll be links to set builder notation in this description if you forgot what that is, okay? If we need to graph the function h of x is equal to 2x minus 1, well, this is from chapter 7. You remember slope-intercept form, right? Take a look at this. This is our y value. Remember, x is the domain, the input, the x value, the x coordinate, and y is the range, the output, the y value, the function of x, and the y coordinate. So this y is the same thing as h of x. See? Same thing. And this 2x minus 1, well, that's in slope-intercept form. That's mx plus b. That tells us our y-intercept right there is a negative 1. Our slope, m, is a 2. See? So we can put our y-intercept where the line is going to intercept the y at a negative 1. Right there. It's negative 1. See? And we need a slope of 2, and that's a rise over a run, right? The vertical over the horizontal, remember? So here's our run, and here's our rise. So for a rise to be 2, it would jump up like this every 2 numbers. See that? And our run would be a 1, so it'd only come over 1, but it would go up 2, go over 1, come up 2, go over 1, come up 2. See that? You can just look at it and see that slope-intercept form. There's the y-intercept b, there's the slope. It's written the same way because f of x, the function of x, is y, okay? Same thing, all right? We've talked about this a lot in the last couple of videos, all right? Let's take a look at this one. It says graph y equals the absolute value of x plus 2. Well, that's the same thing also, isn't it? It looks like it's in slope-intercept form. So we know the y-intercept b is going to be a plus 2. So we can just put a dot right here on the plus 2. And because this is the absolute value of x, and it's going to be like this, if it's 0, if x is a 0, it's going to be on a 2, because it tells us that. And if x is a 1, it's going to be on a positive 3. If it's a negative 1, it's going to be on a positive 3. If it's a 2, it's going to be on a 4. If it's a negative 2, it's going to be on a 4, because we have to add that 2 to it, see? And what will happen is we'll end up with two arrows shooting out like this, and we'll be able to graph the points, see? And we'll end up with y such that this is the set of all y such that y is greater than or equal to 2. And the y-intercept is a 2, so the values of y have to be greater than or equal to 2. See? Can't be any smaller. Okay, our next video is 12.3, and we're going to talk about linear function word problems. And of course, if you want to go to any of the videos that I mentioned about set builder notation or slope-intercept form, those links will be in here, and the previous videos we did, along with my Grade 8 Math Functions playlist. That's the Chapter 6 from Grade 8 Math. Okay? So those links will be in this description to help you out. So let's try solving some word problems for this. All right? See if that'll help you. I'll see you next video. Bye.